I'm Phil Ash from GRIN2B Foundation, and thank you for joining our GRIN2B Hive Webinar Week. Our final Research Corner webinar focuses on our newest grant recipient, Dr. Hongjie Yuan from Emory University in Georgia. Dr. Yuan created a mouse model with a specific GRIN2B loss of function variant. By studying this variant, Dr. Yuan hopes to learn how this specific GRIN2B variant alters the physical and cognitive abilities in the mouse. Following this study, Dr. Yuan will then test the potential drugs D-serin and D-cycloserin to see if they can rescue the abilities lost in the variant mouse. Dr. Yuan's webinar details his progress thus far and provides a timeline for when he expects to complete his research.
Hello, everyone. Thank you for the opportunity to introduce our work on E4-3G mice. Since time limitation, I only have one slide for the background. The patient hosting the variant is a female with profound developmental delay. She rolled by 6 months, sat by 19 months, walked by 4 years old, and spoke only a single word mom at 5 years old. Her psychiatric evaluation at 5 years equivalent as 4 months to 15 months. She was unable to communicate by pointing or signing. She had no daily living skills. She had an unsteady gait, hypotonia, abnormal head movement, and absent pincer grasp. The variant is located in the glutamate binding pocket and disrupt the stability of the agonist binding. Our functional study showed that the activation of the mutant receptors requires much higher concentrations of agonist. The mutant receptor also had a fast and a small synaptic response time calls. Also has reduced cell surface expression, suggesting a strong loss of function. As GRIN2B has long been hypothesized to play a key role in brain development, to further confirm whether the variants account for the patient's phenotypes, we generated a knock-in mouse line harboring these variants. As for phenotype, only difference we noticed that it is a smaller litter size, average 3 to 4 pups per liter. There's no any instance of poor maternal care or mouse sickness. We do not yet know if homozygous animals are viable. There is a tendency that heterozygous female E4-3G mice have a lighter body weight compared to the wild type. However, more measurements are necessary to draw a firm conclusion. We set up 6 pairs of littermates to test if there's any behavior phenotypes. The first test we did is rotoroad assay. The rotoroad assay is used to test the movement coordination. The mice were placed on the road, which accelerates over the time course of 300 seconds. We record the latency. The mouse maintains its balance on the rotoroad prior to falling off the road. The right panel shows there's no significant change in the falling time, although there is a tendency of a shortened latency for the E4-3G mice, indicating the variant has no major impact on motor coordination. The second test we did is locomotor activity. The locomotor activity was tested using this open field system. There are horizontal X, Y sensors and vertical Z sensors. Each infrared beam break was registered as a locomotor activity. We did 2 days of the test. Each day consists 32 minutes blocks for a total 60 minutes. Let's look at the data. Compared to the wild type, E4-3G mice showed a reduced total travel distance, horizontal activity, and movement time, suggesting the variance impairs locomotor activity. We then compare the first day and the second day of for the same genotype. The upper panel is wild type, the lower panel for the E413G mice. Interestingly, the wild type mice showed certain habituation on the second day, reflected as less total distance, horizontal activity, and movement time in the very beginning of the test on the day 2. However, the E4 and 3G mice showed almost identical total travel distance, horizontal activity, and the movement time between day 1 and day 2. We dissect the travel distance with the different time courses. We can see here, the wild type showed more habituation in the first 6 or even 10 minutes of the test when they are put into the box on day 2. Here's the data numbers here. You can see the day 2 and the day 1, there's a significant difference. Our explanation is that the wild type mice knew it was the same box they entered in day 1 and did less exploration. While the E4-3G mice has a quite similar travel distance in the beginning of the test on the day 2. We speculated that the E4-3G mice may not memorize the box they entered on day 1 and may have impaired memory. The third test we did is EZM, Elevated Zero Maze, which is widely used to evaluate anxiety-like behaviors in rodent. There are 2 bright open arms and 2 darkened closed arms. The rodent perceived as less anxious will be more willing to explore the brighter, open, and elevated regions, as opposed to remaining in the darkened and enclosed regions. Each trial will be recorded for about 12 minutes and analyzed by animal tracing code developed in our lab. The mice were tested daily for 5 days. These 2 videos are from 2 littermate. The left side is wild type. The right side is E4 and 3G mice. We can see the wild type mouse was not afraid of open space and can quickly adapt to the elevated maze and move around between the open and the closed arm. While the E4 and 3G mouse from the same breeding stayed in the closed arm almost all the time and never across the open arm. Seldomly, she moved out and do the exploration and then came back. The wild type, once she reach out to the open arms, there's higher chance she will cross over the open arm. This is 3-minute samples from total 12 minutes recording. Okay, let's move on. This is the trajectory traces for the 2 mice showed in previous videos. The left, we can see the wild type mouse move across the open arms many times, while the E4 and 3G mice stayed in the closed arm and seldom come out. Only 1 time in the 10 minutes of the recording, This mice left the closed arm and then returned back, never across over the open arms. Here are plots for the 5 days of the test. We can see there's a clear difference in the number of the open arm crossing and open arm travel distance between the wild type and the E4 and 3G mice through 5 days of the test. Here is the other parameters compared between the wild type and the E4 and 3G on the first day of the testing. This data reflects the E4 and 3G mice is highly anxious. We then did some Gaussian staining to evaluate whether the E4 and 3G variants influence the dendrite spike density. Dendrite spike density is correlated with the memory and the learning. Here are examples of the Gaussian staining of hippocampus CA1 pyramidal cells for wild type and for the E4 and 3G mice. Our preliminary analysis showed that E4 and 3G mice has a reduced dendrite spike density. We are now doing more analysis on this with double-blind manners. A new joined undergraduate now is in charge of this part. We hope we'll have more information in next 1 month or 2. We also performed immunostaining for astrocyte, microglia, and interneurons on 3 pairs of adult mice. Left panels for the astrocyte, and the middle panel for microglia, and the right panels for the interneurons. In each panel, upper blue one is DAPI staining, which is the nuclei. The lower green staining for each specific antibody. Our preliminary observation suggested a comparable signal for the astrocyte and for the microglia. We cannot tell signal for the interneurons. The slide showed here that the E4 and 3G has less interneuron signals. Again, the new joined undergraduate is doing analysis on these images with a double-blinded manner. We hope we will have more information soon. All right, summary. The female E4 and 3G mice may have a lighter body weight. There is no significant difference in rotoroad assay. The E4 and 3G mice showed a reduced locomotor activity with a slower habituation. The E4 and 3G mice showed a significantly reduced number of open arm crossing and a decreased travel distance in the open arms, suggesting a high anxiety. The E4 and 3G mice showed a reduced dendrite spike density and shortened synaptic response time calls. The latter one is a PhD student who is in charge of that. He just got this data last week, so I did not show the raw trees here. We are now measuring more body weight, especially for male mice, and are analyzing Golgi and immunostainings, recording more synaptic activity, and having scheduled to do more behavior tests for example, water maze, fear conditioning to test whether the variants influence the spatial memory and also context memory. We also scheduled to do rescue pharmacology. That's for the update. Many thanks for GRIN2B Foundation. There will be no this data and such progress without your general support. We really appreciate it. Also, many thanks to Steve, who helped on research design and provide valuable inputs on the data collection and the data analysis. Scott for setting up the behavior test. Riley, a talented postdoc who developed the code for analyzing the EZM data. Chad, a PhD student who is doing Patrick lab recording now and also help on immunostaining. Ray is a MD PhD student from China, a major driving force for this project. She's in charge of animal management, doing behavior tests, Gaussian staining, and Patrick lab recording. Ishan, a new joined undergraduate, is analyzing Gaussian and immunostaining data. Eva, a new hired technician, now is in charge of the taking of the animal. Again, thank you all very much for your support. I would like answer questions if you have any. Thank you very much.
So once again, thank you, Dr. Yuan. Really appreciate the summary of the work that has been done so far. It's exciting to sort of honestly see some of the data that I think clarifies some of our own perceptions, and we're excited to see what some of the additional data may find. There's only one question that was submitted by our families, and again, I'm just going to read this more or less verbatim. But your proposal for the work included the following sentence, quote, "We will also assess whether a set of NMDA receptor potentiators and activators, for example, D-serin and D-cycloserin, will be able to reduce the deficits in the knock-in models." So the question is, will you also be testing L-serin as well during this process? And if you are not going to be testing L-serin, why?
Yeah, the L-serin, our previous study on this L-serin, D-serin, D-cycloserin, all of them can potentiate this E4 and 3G variants in our system. But D-serin, D-cycloserin with the highest potency, which means we need only less amount of the compound that can potentiate the receptor followed by the D-serin. L-serin the least. So which means we need much higher concentrations of the L-serin to potentiate E4 and 3G receptors. So our thinking was, if D-serin does not work, there's no way L-serin will work. That's why we focus on D-cycloserin or D-serin. So we can add it L-serin if a timeline of budget allowed, but I think that if we found the D-serin works, I think that is that the information is enough to let us moving forward.
Okay, so just to make sure I have that answer clear, so D-serin and D-cycloserin, they're much higher concentration, so therefore less is needed to potentially affect the variant, whereas L-serin needed a much higher concentration. So in theory, if D-serin and D-cycloserin are effective, or not effective for that matter, then L-serin would not necessarily need to be tested as a result. Is that what you're saying?
Yeah, that's almost there. D-serin and D-cycloserin with higher potency, which means less amount of the compound, less concentration of the compounds needed to potentiate E4 and 3G receptor. While L-serin is less potent, which means to reach same amount of potentiation requires much higher concentrations. Yeah,
I see. Okay, thank you very much for clearing that up. I really appreciate it. And so, the only other question is, how far into this process would you say you are, as far as this grant is going? It sounds like you're getting your way through sort of basic understandings of what the knock-in mouse is showing versus the wild type mouse. And when do you think you'll start testing the D-serin and the D-cycloserin? Like, when will that process begin to take place? What's your timeline for that?
Yeah, before that, we needed to know the memory, how this variant influence memory. The 3 behavior tests I showed today is was performed in our lab. But the memory and the learning test we have to do at Emory Rodent Behavior Center. So that is, due to the pandemic, that is a, long waiting list there. We schedule that we can have this happen in next 2 to 3 months. After that, we need to pick one of the major phenotype, either, memory deficit or this higher anxiety we found in the adult zero maze. Then we test either D-cycloserine, L-serine, rescue pharmacology on that behavior deficit. I think we will have more information in next 2 to 3 months, and we will decide which behavior test we will do.
Understood. Appreciate you clarifying that. Yeah, then I know that the pandemic, it's amazing what the pandemic has done for everything in terms of just kind of slowing things down, but it's exciting to know that, 2 to 3 months from now, we'll have more information and be able to sort of test some of these potential drugs. That's all the questions that I have and that our constituents have at this time. And would it be okay if we shared your email address if people had additional questions? You have to understand this will be viewed in mid-July as opposed to when we're recording it. So it's very likely that some of our families that are viewing this webinar may come up with questions as they're viewing it in July. So would it be okay if we submitted or posted your email address for those questions to be filtered too?
Sure.
Okay. Yeah. All right. Well, I really appreciate the time. Thank you so much, Dr. Yuan, for your time and for your grace in undertaking this study. And I hope it's fruitful for everybody involved.
Thank you so much. Thank you. Appreciate it.